Lesson 1-3, Properties of Numbers. The objective here today is to recognize the properties of equality and identity and commutative and associative. So our objective is to be able to recognize the properties when they are being used. The algebra standards that are involved with these are A1.9.3 and A1.1.3. Really what you need to do is you need to read through all of these properties several times so that you kind of commit them to memory. You need to know these properties. When you get to geometry next year, you will use them all the time in geometric proofs. So it's my job to introduce them to you and have you understand what they are. And then next year, Mrs. Fryman will take you further and make you use them to prove things. So I'm just going to go through each one and try to explain what it is to begin with. So first of all, we have reflexive property. Reflexive property just simply says that something that is equal to itself. So on both sides of the equal sign, it's identical. One thing is equal to itself. That's called reflexive, which seems kind of silly, but honestly, that's the one that you use a lot in geometry proofs, reflexive property. Maybe not as much what we're doing today, but you will use that a lot next year. So something equaling itself. Next, symmetric. So if something's symmetrical, it's the same on both sides, is what I think of. But symmetric property here is if A equals B, then B equals A. It would be equal in either order. However you would need to write it, that would be okay by symmetric property, so you can turn things around. And I think you'll see, now it might seem kind of silly, but you will see that come up once in a while to kind of help with how problems are written. So that's symmetric property. Then we have transitive. Transitive makes a little more sense. Transitive property says if A is equal to B, and then B turns around and is equal to C, then you can conclude that A and C must be equal. So, for example, if you knew that that Mia is the same height as my tree, and my tree is the same height as Tora, then you could conclude, without actually putting them next to each other, that Mia and Tora would be the same height. Okay, so that's transitive. So there's an example there. If 4 plus 7 is equal to 9 plus 2, and you know 9 plus 2 equals 11, then you can conclude that 4 plus 7 must also equal 11. Okay, so that one you might use once in a while. Now substitution, I'm going to tell you, you're going to use that all over the place with our lesson. Substitution is basically, if A is equal to B, you can plug in A for B anytime. You can plug B for A anytime. Anytime you are working out a problem and you go from one step to the next saying that this, like you would do in the steps of order of operation. Oh my gosh, going from one step to the next, that's always substitution because you're putting what it's equal. When you evaluate, you're substituting in what it's equal to. That's always called substitution. So as you're doing your homework over this, when in doubt, put substitution. Chances are you're going to be right. All right? So here's what we're going to do with these. We're going to take some problems that we solved with order of operation, and you go from one step to the next, and you have to justify how you know that's true. So this first example that we're looking at would be the quantity of 3 plus 2 squared. And by order of operations, the first thing you would do would be the 3 plus 2. Well, 3 plus 2, you know, is 5. So that's what you plug in, 5. Well, that is just a substitution. You substituted 5 in place of 3 plus 2. Then next, instead of 5 squared, you would write 25. Again, that's just a substitution. You plugged in one thing for the next and what it was equal to. So that's using the properties of equality, and you'll be using those for problems today. Okay, some other properties, okay, the identities. There's an identity for addition and an identity for multiplication. Basically, an identity doesn't change a number's identity. So for addition, it's called the additive identity. When you add 0, that doesn't change the value. A plus 0 equals A. That's called the additive identity. Multiplication is called the multiplicative identity. When you multiply by 1, it doesn't change the value. So that would be A times 1 equals A. All right, that's the multiplicative identity. All right, questions on the identities. All right, we're going to look at inverses. Inverses deal with opposites, okay? And again, for the inverses, you have addition and multiplication. Both of them have inverses. For the additive inverse, you are adding opposites, A and negative A, to give you 0. And multiplicative inverse, you multiply A over B and B over A, because what happens when you multiply those things, everything cancels out and it becomes 1. So basically, the additive inverse and multiplicative inverse, it's what gives you their respective identity. The identity in addition is 0. So additive inverse are the two numbers that give you 0. Multiplicative identity is 1. So the multiplicative inverse are the two numbers multiplied together to give you 1. Now, in plain English, or what you're used to, multiplicative inverse is really the reciprocal. It's really the reciprocal. When you multiply reciprocals together, you get the number 1. All right, the last couple of properties, the multiplicative property of 0, kind of self-explanatory. Anytime you multiply by 0, that's what you're going to get, 0. Commutative property, you've touched on this in the past. Commutative means that you can do the problem in either order and it does not change the value. You have commutative property of addition, so you can add A plus B and it's the same as B plus A. Or commutative property of multiplication, A times B or B times A. Subtraction and division are not commutative, but addition and multiplication are, and I think you already know that. And lastly, associative property. So associative means that you can reassociate the problem and you still get the same answer. So associative property, one thing that you should just be aware of, A plus B plus C, they're in that order on the left. A plus B plus C, they're in the exact same order on the right. It's just the parentheses change. It's just the parentheses change. And you know what? Don't be tricked by seeing a problem with parentheses and just saying, oh, that must be associative, because that's not true. Let me give you a really quick example. So you might want to write this down. If you were asked to identify properties, here's one that's kind of tricky. Let's say you saw 5 plus 2 plus 3 on the left, and on the right it was written like this. So on the left it's 5 plus the quantity of 2 plus 3, and on the right it's the quantity of 2 plus 3 plus 5. Which property is that one, Ben? Commutative. Okay, it's kind of a tricky commutative. You see the parentheses, most kids would say, okay, 3 things, parentheses, must be associative. But remember about associative, I said they're in the same order. Well, on the left it's 5, 2, 3, and on the right it's 2, 3, 5. So this one would be commutative property of addition. Okay, so commutative property of addition. So don't be tricked by that. Questions there? Ben?
When we do it, will we have to put like in the end of it, like this is manpower?
You'll have to write it out, and yes, if it's addition or multiplication, and you may use abbreviations, but yeah, you do have to write it out like that. Okay. All right, so let's look at some examples now. This says, find the value of X and name the property used. So basically, you're solving something and are seeing what would fit in there and then tell what property it would be. So example A says 3.2 plus X equals 3.2. So the first thing you're going to do here is say what X would have to be equal to. And what would X have to be equal to, Avery? 0. And can you tell me, out of that list of properties, what would the property be called that would tell you that? When you add 0 in, what's that called? It's in the last set of, second last section there. When you're adding 0 and it doesn't change the identity, it's called the So what operation are we using?
Multiplicative property.
No. We're adding 0 and it doesn't change the value. So it's called the additive identity. So you could do add ID. That's how you could abbreviate that. Add ID. Okay. B. 1/7 times blank equals 1/7 times X equals 1/7 times 7. What would go in place of X in order for that to be equal? Tora? What? 7. And what property would that be? No, it's 1/7 times 7 equals 1/7 times 7. The left-hand side equals the right-hand side. What property is that? No. No, look at the top of your notes. The left-hand side equals the right-hand side. So where the left equals the right, it would be called, not symmetric. Symmetric changes it around. This one has the same, it's reflexive because it's exactly the same on each side. Reflexive, you can just put reflexive. It's reflexive property. Okay, 1 times X equals 3. What would X have to be? Octavia. 3. Can you tell me what property that would be? So it is the multi-ID, the multiplicative identity, and that is exactly right. Okay, so be able to do that.